NASA's James Webb Space Telescope
has captured unprecedented and really beautiful images of the sun's surface.
Imagine you could be susceptible to misleading ideas about space. However, take comfort in the fact that many of us have been exposed to inaccurate information when it comes to space. Our knowledge of the universe is progressing so swiftly that even the most brilliant astronomers must constantly adjust to new discoveries. It's no small feat. So here's the question: how many of the lies about space do you hold? Have you ever pondered the accuracy of your space knowledge? Surprisingly, movies have been feeding us misinformation for years. In this episode, we'll delve into some of the most significant misconceptions about space. This is Reveal the Mystery. If you are curious to learn mysteries of the world, space and beyond, consider subscribing. 1. Space is cold. Space may appear frigid, but it lacks an inherent temperature altogether. Temperature is a measure of particle movement speed and energy content, and in the true vacuum of space, particles are absent, resulting in a temperature-less environment. It's worth noting that outer space isn't a perfect vacuum. It contains particles and radiation that can generate heat. Some regions of space, particularly those in close proximity to stars, can be notably hot. However, as you move away from stars, the particles become more dispersed, leading to colder areas in space. Certain dense gas clouds, for example, can plummet to temperatures as low as -263 degrees Celsius. 2. There is no sound in space. In space, there's no air or anything for sound to travel through like it does on Earth. So, when big things like exploding stars or crashing black holes happen in space, they don't make any noise that we can hear. However, in some parts of space, where there are lots of particles, like the gas cloud around a black hole in the Perseus galaxy, sound can actually move around. This lets us hear a unique sound from the black hole. Even planets can produce sounds, but that's a topic for another time, when we explore it further. 3. Planets do not orbit around the Sun. Within our solar system, planetary motion is more complex than a straightforward orbit around the Sun. It involves a delicate balance despite the Sun's immense gravity. Planets and moons don't just orbit the Sun, they also move around a shared center called the barycenter, situated between them and the Sun. For Earth, this point is very close to the Sun's core, making little difference. But for Jupiter, it's about 55,000 kilometers away from the Sun's center. This gravitational interplay defines the dynamic motion of celestial bodies in our solar system. 4. Explosions in space. Now, regarding the idea of fiery explosions in space, they are, in fact, non-existent. Spaceships cannot erupt into violent blasts in the vacuum of space because there is no air, and without oxygen, fire cannot occur. Apologies to Star Wars enthusiasts. 5. You can't count stars. While the night sky might give the impression of an abundance of stars, it's indeed feasible to enumerate them, and this endeavor has already been pursued by researchers from Harvard. As indicated by the Yale Bright Star Catalog, there are 9,110 stars that can be observed from Earth without the aid of telescopes or binoculars. If you so desire, you can take on the challenge of counting them independently. 6. You can't fly through the asteroid belt. Movies often depict the asteroid belt as a treacherous challenge, suggesting that navigating it requires exceptional piloting skills. However, this portrayal is not accurate. The asteroid belt does not resemble a dense, deadly obstacle course. It consists of trillions of space rocks that vary in size. Approximately 100,000 of these asteroids measure over 1 kilometer wide, but they are widely dispersed. Situated between Mars and Jupiter, the asteroid belt spans a vast distance of 225 million kilometers. This expanse is 1.5 times the distance from Earth to the Sun. Consequently, these space rocks are spread millions of kilometers apart, making it highly improbable for a spacecraft to collide with one. 7. You instantly freeze in space. If hypothetically you were ejected from an airlock into the immense void of space, you wouldn't immediately freeze solid. This is because the process of freezing requires heat transfer from space to your body, and heat or cold does not propagate swiftly in the vacuum of space. While your body would eventually freeze, this would take hours, and you would likely succumb to other factors long before that occurred. 8. You explode in space. In contrast to what many believe, you wouldn't undergo an explosive event when exposed to the vacuum of space, but rather, you would go through a process of expansion. This expansion arises from the nitrogen in your bloodstream accumulating into bubbles, causing your body to swell to nearly twice its regular size. However, it's important to note that this inflation isn't the cause of your demise. The critical factor leading to fatality would be the severe oxygen deprivation. Within a mere 15 seconds of being in space, your brain would be deprived of adequate oxygen via your bloodstream, resulting in a loss of consciousness. Within 2 minutes, your other bodily organs would gradually cease functioning, ultimately resulting in a grim and unfortunate outcome. 9. The sun is yellow. Contrary to the widely held belief that the sun is a blazing yellow orb, its actual appearance is more complex. The sun isn't truly yellow, it tends toward a greenish shade. Scientists assess a star's temperature based on the colors it emits, with cooler stars appearing reddish and hotter ones taking on a bluish hue. The sun predominantly emits green wavelengths, which mix with others, creating a bright white appearance when observed from the International Space Station. However, when viewed from Earth, our atmosphere scatters blue light, resulting in the sun appearing yellow. 10. The sun on fire. However, this isn't the sole misconception to rectify. While the sun is undeniably hot, it doesn't undergo combustion like a fire. Burning is a chemical reaction involving oxygen and fuel. Unlike most stars, our sun is primarily composed of hydrogen and helium, with minimal oxygen. Instead, it functions akin to an enormous nuclear reactor, perpetually fusing hydrogen atoms within its core to generate helium. This process releases prodigious amounts of energy, accounting for the sun's scorching heat. 11. Mercury is the hottest planet. Although Mercury is the nearest planet to the Sun, it doesn't hold the record for being the hottest in our solar system. Instead, it undergoes dramatic temperature shifts, soaring to scorching daytime highs of 430 degrees Celsius and plummeting to frigid lows of -180 degrees Celsius at night. In stark contrast, the most inhospitable celestial body in our solar system is Venus. This distinction arises from its thick atmosphere, which adeptly traps and retains heat, generating a potent greenhouse effect. Consequently, Venus becomes a blazing inferno, with surface temperatures reaching a scalding approximately 475 degrees Celsius. 12. The solar system stays in place. The entirety of our solar system doesn't remain fixed in our galaxy. Instead, it's in constant motion, hurtling through space at an astonishing velocity of 220 kilometers per second. This speed is 7 times swifter than Earth's orbital pace around the Sun. Remarkably, our solar system requires a vast span of 230 million years to complete a single orbit around the Milky Way. To provide some context, the last instance when our solar system occupied its present position, Earth was part of a singular supercontinent, and the age of dinosaurs was in its early stages. 13. The Earth is a sphere. While Earth may appear spherical from space, it is, in fact, an irregularly shaped ellipsoid. Its bulging shape at the equator is the result of centrifugal force generated by the planet's rotation. Consequently, Earth is approximately 43 kilometers wider at the equator than at the poles. This disparity results in slightly weaker gravity at the equatorial bulge, making it more favorable for launching spacecraft from equatorial regions compared to the poles. We hope you liked this video. Don't forget to like and subscribe. Goodbye.